Okay, so we managed them giving us the name of an alkene, and then we draw a condensed structural diagram. This is the same thing, only now they want a line structural diagram, so just lines mostly. Reading this, I see blah 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 but1-ene. Start with this part, and then we'll attach the branches to it. But means 4 carbons. Oops, I'm not writing the carbons. Or am I? Now we'll be okay. So there's 1 carbon to start. 2, 3, 4. That's butane. 1 carbon, 2, 3, 4. At the end of every line is a carbon. But1-ene means starting from the first carbon there is a double bond, so there should be 2 lines coming off of there. And, sorry, just to make this clear, I drew that dot just because I was counting and it helped me to get started, but really these should be straight lines. There's nothing connecting those at the end. It's understood there's 1 carbon that's attached to both of those double bonds. So there is but1-ene, and now it says 3-methyl. So on the first carbon, on the third carbon, that's number 1, number 2, here's number 3, there is a methyl group, which means 1 more carbon atom. So just that. Next thing here, blah, 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 hept1-ene. Start there. Hept means 7 carbons. So from the start, 1, 2, 3, 4, 5, 6, 7. That's heptane. Hept1-ene means from the first carbon, draw a double bond. So, yeah. Now we have hept1-ene. Now for branches, on the second carbon, put an ethyl group. That's 2 carbons. So here's carbon number 2, and then we go 1, 2. There's our ethyl group. Could you go that way? Yes. I tend to bend it out this way because Vesper taught us that electron pairs want to repel, and so all things being equal, these electrons would rather be further away from the big mass of electrons in the primary chain. That's not an overwhelmingly strong reason, but it's what I'm thinking of when I angle these things away. So that's 2-ethyl hept1-ene, and now on the third and fourth carbons we put methyl groups. So first carbon, second carbon, that gets a methyl group, and that gets a methyl group. And that should about do it. One more of these. 3-ethyl 4,5-dimethyl hex1-ene. Start with this, of course. 6 carbons. So from the start, 1, 2, 3, 4, 5, 6. 1-ene means from the first carbon. They always seem to start at 1. They're in a bit of a rut on their numbering. But, oh well. Okay, so there's hex1-ene. On the third carbon, 1, 2, 3, put an ethyl group. That's 2 carbons worth of branch. Ooh, a little messy. Let's make that nicer. This isn't a hexagon, but I try to imagine that there was a hexagon there, and I try to make the sides match nicely so that it's a hexagon with some missing sides. If you're doing that, the proportions come out nice, and you get a nice, clean, professional-ish looking drawing. Okay, so that's 3-ethyl. Now on 4 and 5, we put methyl groups. 1, 2, 3, 4 gets a methyl group, and 5 gets a methyl group. The angles I'm picking for these and the directions that I bend things are not necessarily the same that other people are going to use, so if you see another version of this, try not to let it throw you. Identify the primary on whatever it is that they drew, and then just start counting out where the branches are and how long the branches are, and hopefully you will find that we all agree. And hopefully I will see you in the next lesson.